What is happening?
Maybe you're just trying to get buttons off your pants.
Oh, maybe, but it's my ass.
You don't have ass buttons?
No, not on my jeans. I have ass buttons. Ass buttons. There's a song in that somewhere. All right. Give me some events. What could happen? Flipping the coin 3 times.
You get all heads.
You get all heads, right?
All tails.
All tails.
Head, tail.
All heads. All tails.
Head, tail, head.
2 tails and a head.
Tails, head. 2 heads.
2 tails, 1 head. Let's do it that way. And then 1 tails and 2 heads.
Or then tails, head, tail.
Well, that would be this. Tails, head, tails will be in here. Ah, I see what you guys are doing. I see. Oh, I love what you're doing. You're actually enumerating all the outcomes.
Right.
Oh, good. So here's a question. Here's a question. Before we do that, would I be correct in saying each of these is 25% likely?
Yes.
So that's 25%, 25%, 25%. Here's, I want to do Sean's theories in purple.
There's 2 other events that could happen, isn't there?
Well, as far as numbers of heads and tails, what will the 2 be, Mel?
2 tails and 2 heads.
Well, for the 3 times though.
Oh,
No, we're getting to 4. I promise you. Yes, and there will be another event when we flip a coin the 4th time. It'll be 2 and 2 for sure.
Getting ahead of myself.
What do you think?
You're
Quarter. Sound like an auctioneer.
3 coin. 3 coin. Wouldn't it be?
Well, first of all, time out. Does this add to 100%?
Yes.
Okay, so it passes that test. Are they correct, Mel?
Wouldn't it be thirds because you could have all heads or tails and then 2 tails, 1 head?
Well, I'll tell you what. Let's answer your question with some data collection. Okay? Let's raise hands and show me how many of you got 3 heads. So how many of your trials were exactly 3 heads? Let me see fingers on this one. So you flipped the coin 3 times, and you did that 10 times. So technically speaking, 30 flips, right? So how many times did you get 3 heads? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I get 19 of those.
Wouldn't it be 1 and 6?
I hear a vote for 1 and 6. Right here? Good. I don't know. We're going to figure this out. Because what we're going to do is, Natasha, I love where you were going with that. With the tails, heads, tails. I love that. But in general, the data has to actually show us where to go. So let's see where the data points us, okay? Let's see where the data points us. While we're there, let's go with all tails. How many times did we get all tails? So a sweep of tails, TTT. TTT. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9. 29 of those. How many did we get? 2 tails and a head. Like hand and fingers. So 2 tails and 1 head. And I don't care where the tails were. I'm not saying it had to go TTH. Just how many times did you get 2 tails and 1 head? 2 tails and 1 head. All right, so we got 4, 7, 11, 14, 16, 24, 27, 32, 36, 2 hands back there, very nice, 42, 44, 48, 51, 53, 57, 59, 66, 72. How about 1 tail and 2 heads? And again, I don't care where the heads are or where the tail is, just that there was 1 tail and then 2 heads somewhere. I want to get back to Natasha's point here momentarily. Oh, what you got?
73.
Oh, 73. Okay. Thank you.
Yeah, and the one above it needs to be 30.
Okay. All good. I'm usually off when I count, as you guys have noticed. All right, ready? So 1 tail, 2 heads. 6, 10, 19, 25, 26, 36, 42, 43, 47, 52, 55, 59, 62, 65, 70.
And 1 more, or 3 more.
73! 3 more. Okay, I can't count very well because it doesn't add up to something that ends in 0. Because it should be 190, I would imagine, if I add it up correctly. What does it add up to? It doesn't matter. I'm sure I uniformly screwed up across the board. That's 49 plus 146, right? So this is going to be, if that's 50, that's 195. I'm off by a little. I can live with that. I probably screwed up at least one in each. So, based on that, good! Thank you, Aaron. What are my percentages? What percent of the time? What I really want to know is, what's the probability of all heads? What's the probability of all tails? What's the probability of 2 tails and 1 head? So we're going to do it 2 different ways. Probability of 2 tails and 1 head. And what's the probability of 1 head? Nope, 1 tail and 2 heads. So the first way we're going to do it is purely empirically, which is using the data we just collected. Use the data we just collected and form the ratios. Well, we had 195 trials, or at least we had 195 things that I counted. Of those 195, 19 of them, out of the 195, came up all heads. What does that end up being? That ends up being 20 out of 2, about 10%. It's a little bit higher than 10%. What do you guys get?
0.09.
Oh, it's a little under 10%. Okay, 9.7%. Thank you. Trying to do too much math in my head. It's a bad idea. All tails, that was 30 out of 195.
0.15.
15%? Oh, 0.15, not 0.15. That makes sense. That makes sense. 50% more-ish. 2 tails and 1 head is 73 out of 195.
0.37.
Thank you. I was going to say it's like 3/8 because that's like 75 out of 200. Thank you. And this also is going to be the exact same thing, isn't it? The exact same number. So what it looks like to me is that my original guess of 1/4, 1/4, 1/4, and 1/4 is absolute crap. Absolute crap. And you can see what you guys might not be able to see it because I might not be able to see it. Excuse me for going filling on you. You probably couldn't see it, but when I started asking for how many times this occurred, you guys started using 2 hands in some cases to hold it up. Nobody held up 2 hands for all heads and all tails. It was always on one. Oh, Janelle, go ahead.
I was going to say there's like 1/8, 1/8, and 3/4.
Did you hear what Janelle just said? This is also related back to your last project. I don't know if it was one of the ones I had you turn in or if it was one of the examples. I'm not sure. But Natasha, you started breaking this down for us before. And I'm going to go over this way a little. No, we're going to go this way. Can I erase this over here? I think we've got this idea pretty much. You saw that this is what we just did. We just did this to get those numbers. Now, what you can actually do, however, is list out all the outcomes for this. Let's list it out. If you flip a coin 3 times, give me one of the outcomes. Heads, heads, heads. Boom, boom, boom. Tails, tails, tails. Okay.
Heads, heads, tails.
Heads, heads, tails is one outcome that falls under this jurisdiction right here.
Tail, tail, head.
How about tails, tails, heads? That's one of the ones that falls under the jurisdiction of this one right here.
Head, tail, head.
How about heads, tails, heads? That would be under this jurisdiction here, wouldn't it? How about tails, heads, heads while we're at it? Wouldn't that one also be under that jurisdiction?
Yep.
Now, if that one's got 3, shouldn't this one have 3 as well?
What about tails, heads, tails?
How about tails, heads, tails? Or, how about heads, tails, tails? There's 8 possibilities for this experiment. There are 8 possibilities. Think back to your last project as to why. Every time you flip a coin, how many results possible are there? 2. When you flip a coin twice, it becomes 4 because it's 2 times 2. The tree splits. 1 branch, 2 branches. If you flip a 3rd coin, each of those 4 branches gets 2 more. So you're going to have 8 outcomes, and there they are. 8 outcomes. Now, of those 8 outcomes, one of them was all heads. Which means the theoretical probability of all heads should have been 1/8, which is about 12.5%. That was a little bit low, but it's not that far low. This should also be 1 1/8, because there's 1 out of the 8. Do you guys see how we are now switched over to the theoretical classical definition of probability? Because we know all the 8, we know the sample space. There are 8 possibilities, and we're counting how many times we are falling into that 8 possibilities. 1 out of those 8, which again is about 12.5%, which is dead. This one's a little bit under, that one's a little bit over, but they're hovering pretty close to it, yeah? And last but not least, how about 2 tails, 1 head? Well, let's see, 2 tails, that's this guy. and these two guys, right? There's 2 tails, 1 head. That's 3 and 8. 3 and 8 as a fraction is about 38%. Damn. Perfect. Well, perfect-ish. Perfect-ish. And guess who else is 3/8? 2 heads, 1 tail, which is also 3/8. Pretty slick, huh? Pretty slick. Pretty slick. So, our original guts led us kind of in the right way. I heard Frankie say, wait, what should be 1 and 6? I love that. No. You were going the right way with it. And Janelle, you said it should be 1/8, 1/8, and 3/4. Because what you were doing was the chance of all heads, the chance of all tails, and the chance of a mismatch. And a mismatch can be further broken down if you want to, of course, by saying 2 heads, 1 tail, 2 tails, 1 head. Hell, you can make this have 8 different outcomes if you want. You can say chance of all heads, chance of all tails, the chance of tails, tails, and then heads. The chance of heads, heads, and then tails. And then it would be 1/8 all the way down. But very often you don't bet on things like that. If you're playing craps, you do sometimes. Play on 8 the hard way or 10 the hard way, which is not just a sum of 10, but a certain specific way of getting 10. More on that on Wednesday. We'll start rolling the dice on Wednesday. But generally, you want to talk about the number of results within a given outcome. 2 heads out of 3, 3 heads out of 3, 1 head out of 3, something like that. Pretty slick, huh? On average, how many heads should you see if you flip 3 coins? On average, how many heads? On average. On average. Don't think about this too hard. Go back to the beginning. Go back to the beginning. On average, we should see 1 head for every 2 flips of the coin, right? Which would be 1/2 of a head per flip, on average. This upset the guy at the feed store when I said, so you're telling me this little thing is 0.9 girl? He's like, no, I'm telling you it's a boy or a girl. I'm like, yeah, but it's 90% girl. You just told me. And he was getting freaked out with me. Understandable. But then I told him something useful. Well, I'll come back to that. So, on 1 flip, expect 1/2 of a head on average. On 2 flips, expect
4.
On average, how many heads? I'm sorry. On average, 4 outcomes. But on average, how many heads? I'll give you the answer. I didn't realize it. I'll give you the answer. 1 head out of 2 coins, right?
Because it was 1/2.
Because it was 1/2, so half times the 2. How about for 3 flips? How many heads should you average? 1.5. Half of the flips should be heads, and half of them should be tails. Averages don't have to make numerical sense. You can't actually flip 1/2 of a head, but you can average 1/2 of a head, can't you? Does that make sense? You can average 1/2 of a head. Well, you can do a weighted average if you wanted to. Check this out. Let's see how close we get. Let's do a weighted average of our results. So now you're curious. See how our data came out. All right, let's go over here. Let's do a weighted average of our results.